Imagine shrinking 100,000 times smaller than a grain of sand. You would enter a world so tiny, it defies our everyday understanding. You find yourself in the realm of nanophysics, a fascinating domain where the rules of classical physics no longer apply. This is a world governed by different rules, where particles behave in ways that seem almost magical. Here we encounter nanoparticles, tiny bits of matter with astonishing properties. These particles come in various shapes and forms, each with unique characteristics. These minuscule particles hold the key to revolutionizing our world. They interact with their environment in ways that can lead to groundbreaking technological advancements. Nanophysics explores behaviors of matter at this incredibly small scale, revealing new phenomena and potential applications. At the nanoscale, materials often display unexpected properties, such as increased strength, lighter weight, or enhanced chemical reactivity. These unique characteristics stem from the quantum world, where particles can exist in multiple states at once and influence each other instantaneously. Nanoparticles are like tiny building blocks with enormous potential. They can assemble into larger structures, paving the way for innovations in medicine, electronics, and material science. Creating nanoparticles is like following a precise recipe, where every step and ingredient must be meticulously planned and executed. Scientists use various techniques, each resulting in different structures and properties of the nanoparticles. These techniques are often complex and require a deep understanding of chemistry and physics. One method uses lasers to vaporize materials, which then condense into nanoparticles. This technique allows for precise control over the size and shape of the particles. Another approach employs chemical reactions to carefully assemble atoms and molecules. This method can create highly uniform nanoparticles with specific properties. Imagine baking a cake. You combine ingredients like flour, sugar, and eggs in precise amounts to achieve the perfect texture and flavor. Similarly, scientists carefully select and combine atoms and molecules, ensuring that each component is added in the right order and quantity. These building blocks come together in specific ways to form the desired nanoparticles, each with unique characteristics and potential applications. The process demands precision and control, as even the smallest deviation can result in vastly different outcomes. This meticulous attention to detail is what makes nanotechnology so fascinating and powerful. Nanoparticles can arrange themselves in fascinating ways, much like bricks forming a wall. These tiny particles, often just a few nanometers in size, have the remarkable ability to self-organize into complex structures. This process is driven by the inherent properties of the nanoparticles, such as their shape, size, and surface chemistry. Sometimes they assemble spontaneously, guided by their properties. This spontaneous assembly can occur in a solution, where nanoparticles move and interact until they find a stable configuration. Think of magnets snapping together due to their magnetic forces. This analogy helps us understand how nanoparticles can be drawn together by various forces, including electrostatic and van der Waals forces. Other times, scientists guide the assembly process, creating specific patterns. By using techniques like electron microscopy and atomic force microscopy, researchers can manipulate nanoparticles with incredible precision. These arrangements influence the properties of the resulting material. The way nanoparticles are organized can determine the electrical, optical, and mechanical properties of the material. For instance, nanoparticles arranged in a tight, ordered structure might create a material that is incredibly strong. This dense packing can enhance the material's strength and durability. On the other hand, a more loosely packed arrangement could lead to a highly porous material. Such materials can be useful in applications like filtration, where the porous structure allows for the passage of fluids while trapping unwanted particles. The potential applications of nanophysics are vast and inspiring. Imagine bandages that deliver medicine directly to wounds, speeding up healing. Picture solar panels that capture energy more efficiently, reducing our reliance on fossil fuels. Nanoparticles could revolutionize electronics, leading to faster computers and smaller devices. In the future, nanotechnology could even help us clean up the environment, removing pollutants from the air and water. The possibilities are limited only by our imagination.